Welcome to Haxby Shed and the welding rotator, part 6. I've just rigged up a reverser switch. Now when this inverter is driving the shaper, we don't need a reverse. But for this, what I've realised is when you were doing stick, you'd want it spinning in one direction, but for TIG, I think you'd want it spinning in the other direction. We'll see if that's borne out by experience, but that's what it feels like in my brain anyway. Now when I flick this switch, we'll see this ramp down by 6 seconds, and then it will ramp up to reverse over 6 seconds. Now when I get my new inverter to drive this, I won't have it set up with a 6-second ramp down and ramp up. There just isn't any need. Maybe 2 seconds, something like that. I've cut myself again. How? I haven't done anything. Never mind. There we are. And as I look at the current on this meter over here, you probably can't see it because something's in the way. How about that? Look. Then it's reading 0.409 of an amp. And this motor maximum current rating at this voltage is 0.42. I've just cleaned up this bit of scaffolding pipe to give me something to practice on. I'm setting up for my first test weld. I'm going to use stick, 95 amps, DC, earth negative. I've got my test piece, which I'll put in the chuck in a moment. I'm not going to try anything ambitious. I'm just trying to weld a circle, that's all, on the side of this. Now my welding isn't great. I don't claim to be a good welder, so please judge the rotator and not my welding when it comes to it. I've got the earth cable here, just clamped on the end. Now probably I could have bought a longer cable. Maybe I will. And if I replace this cable, I would try and find an insulation which was heat proof. This one definitely isn't. I'll need to make sure this doesn't touch this or any other metal on the bench, otherwise there'll be 2 circuits, earth circuits, between this and this chuck, and it could burn the bearings. Now maybe it wouldn't, maybe it would, I don't know. As I start to weld, we're going to be testing this connection between this copper plate and the earth here and the chuck. It's not impossible, of course, that there'll be some burning between these two. I don't know yet, I've never tested it. If there's any burning, of course, it's going to melt this insulation. It won't electrocute me, but it'll certainly spoil my day. Okay, let's get it set up. I'll have to check the sort of test rotation speed and get a feel for whether or not it's set about right before I try striking an arc. Well, it's spinning the right way, but obviously too fast. I've got to go over here now to slow this down. When I get a proper setup, of course, I'll have all these controls within reach. As a rough guess, that's 4 RPM. Just looking at the frequency reading on the inverter. Well, I'm not going to embarrass myself anymore with terrible welding, but you can see the rotator works. There's no heating or burning or anything between this copper plate and this back plate here, so that much of it has worked very well. That tube is alloy steel, a piece of scaffolding pole, and the rod was a 6013. Nevertheless, my welding is an embarrassment, but the rotator's okay. Well, just to prove that even at this stage you can make the most stupid of mistakes, I took the chuck off to adjust this spring here, and when I took the chuck screws out and looked at them, I can see copper on the ends, so they're too long, and they've been rubbing on that plate. Now that I've taken them out, there's no vibration or anything, and that could have been part of the problem from the beginning whenever the chuck was on. Back to school. I'm going to try a bit of TIG. No filler wire, just the heat. It's heating it okay, but it won't weld without filler. I've had a bit of a setback. I've discovered that the jaws on this chuck are very badly bell-mouthed, like that. Now when I say badly, I mean like this. So I'm going to have to regrind these at some point. The main body of the jaws are fine, it's only the jaw itself. I'll do that some other time. Bit disappointed. I need to go for a coffee, I'm a bit fed up. Well, I don't know where we are with this video, and I'm the one making it. We've just seen that these jaws need dressing. Disappointment. But I can fix that. But I'm still not happy with the sound of this gearbox. It just makes more noise than I think it should. We know the welding rotator design is fine. So all of that side of things, you know, those risks have been put to bed now. But I'm actually going to drain the oil again on this gearbox, see if I can see anything wrong, and I may strip the gearbox down. Let's start with the oil anyway. Well, it was purple when it went in, it's not very purple now. Cover off, fan off, screws out, wiggle this off, wave washer on the end of that bearing. It does seem loose, doesn't it? Right, there's 4 cap heads in here, which I'll take out and hopefully I can extract this. You'd think that there'd be a bearing here and a bearing on the other end, this end. I don't know. We'll find out, won't we? It's coming slowly. Oh, there is no bearing on the other end, look. The bearings in this half seem to be fine. Feels very smooth, it's not grindy or jerky at all. This worm is held on with a press fit and a keyway. There was a snap ring at the top here where the spindle nose comes through this worm, and this snap ring was down against the bearing. Now my hope is that as I press down, this snap ring will come up against this bearing and press this worm off. Ah, good. The worm is pressing off. That's good. Try not to drop this thing. I can feel it now. That bearing's rough. That's the problem, I think, for the noise. Wouldn't have affected the performance, I don't think, but that's where the grumbling is coming from. With this tool, which is kind of hooked, I managed to get the seal out without damaging it. Nothing wrong with this bearing, look. But they're cheap enough, so I'll probably get a pair. Some days later, 2 bearings and a seal. £8.50 delivered. SKF, these 2 bearings. I've cleaned this gearbox out here, got all the oil out, and I flushed it out with brake cleaner because I know there's nothing plastic in it now. The feel of that is very smooth. There's a bearing there and a bearing there. So I'm happy that's fine. So let's get these pressed on now. I'm just pressing on the centre of that bearing, not the outer. You can see it spins. This bearing is just a fraction loose in here, so I'll put a little bit of Loctite in. I think this will go with my fingers. Yes, there we are. Now we can press this shaft into this bearing. That's standing up on a bit of tube, so that once again I'm pressing on the bearing's centre, I'm not pressing on the outer. Another snap ring. Now this worm has to go on, but it's quite tight even from the start, and I'm going to warm it up because otherwise it'd be very difficult to locate this keyway. It soon cooled down, but I was just able to get it on here before it seized again. Now I can press it on with confidence. Now I know that the keyway is engaged. And now another snap ring, the last one. I've just put the slightest smear of silicone on this. Remembering as well to put the big O-ring on. There's still a bit of movement on this, but I think that's because these are C3 clearance bearings. They're intended for motors like this that run 365 by 24, so the thing can run pretty hot, and they're specified to run hot. But as a consequence, they need more clearance in the bearings. Once the thing's all properly warmed up, the clearance will be right. These are in, so I just replace them with the same. I knew I'd put those marks on for a reason. That's better. Not forgetting the wave spring washer and lining up my marks. Put the 3 screws in. Now the fan retaining spring. Just a spring clip really. Now the fan. Now the fan. And now the fan. Goodness me. 110 millilitres ish. Right, let's try it now. Full speed. Now let's turn it down to about 2 RPM. I can't hear anything, can you? I think that's about 1 RPM. Very smooth. Better stop it while I do this. Nearly forgot the silicone grease on this seal. How many times have I done this? I'm just trying to get this spring set right. Too tight and it'll stall the motor. Too slack and the chuck might tip or something, or we might get burning here. That feels about right. That's about 1 RPM and it's been spinning quite happily. I will look out for some kind of wave spring to go in here. Something that isn't quite so strong. It will give me a bit more adjustment. Right then, that's as far as I'm taking this now. I will sort those jaws out on another project. Famous Bob asked me, how much torque does it have at 2 RPM? This is Famous Bob, by the way. Let's try. Don't know what's going to happen. Come on. Grip. Here we go. Hold your breath. I'm sorry, this is playing out very slowly. We should have some dramatic music, really. Ta-da! Well, the answer is enough torque to pull up this brake disc rotor. That's how much torque it's got. At least that much torque, actually. Does that answer your question, Famous Bob? Well, I hope that was useful to you. I think we'll end the series here. Thank you for watching. Hacks be shared.